Okay, so I just wanted to show you real quick how to do a problem like this. You have some of these on your homework, but this problem says to form a 6th-degree polynomial f of x with real coefficients and a leading coefficient of 1 with the following zeros. We have x equals -3 minus 3i. So here we have a complex zero with an imaginary component. 0 is another one of our zeros. And then we have -2, which has a multiplicity of 3. So that factor that's associated with -2 will have an exponent of 3. Now, one thing to remember is that if a polynomial has real coefficients, then if you have a complex zero, like here we have a plus bi, then its conjugate, a minus bi, must be a 0. So for our problem here, we have a 0 of -3 minus 3i. Its conjugate must also be a 0 because our polynomial f of x has real coefficients. So if you remember in a previous lesson, we showed that when you have complex conjugates, part of the simplifying process causes the imaginary components to disappear so that you only have real coefficients. So let's go ahead and form our polynomial. This is a fairly simple problem here. So we have f of x equals, all right, so we're going to have x minus, we have -3 minus 3i times x minus, like I said, if you have -3 minus 3i, then its conjugate will also be present as a 0. So for the factor, you're going to have x minus -3 plus 3i. So that's the conjugate of -3 minus 3i. We have -3 plus 3i. And then we have a 0 as one of our zeros. That means one of our factors must be x. And then -2 is one of our zeros, and it has a multiplicity of 3. So then the factor associated with that, which is x minus -2, that's going to have a power of 3. So here we have our 0, -3 minus 3i. Its conjugate, -3 plus 3i. The 0, 0, right, x equals 0. We have the 0, -2 with a multiplicity of 3. So now let's go ahead and simplify this. So one part of this process is done here, just writing down the factors. Now we have to multiply them out. So we have x, I'm going to use the distributive property here. If I have a negative right here and I distribute it to both of these, all it does is change the sign of them. So this is going to be x plus 3 plus 3i. Okay. Same thing here. I've got the distributive property. So I've got x minus -3 is plus 3. And then negative times positive 3i is going to make minus 3i. Times x minus -2 is plus 2 cubed. Okay, so let's go ahead and multiply this out. So I have x times x, which is x squared. X times 3 is 3x. X times negative 3i is minus 3ix. And then I have 3 times x is 3x. I have 3 times 3 is 9. I have 3 times negative 3i, that's negative 9i. And then I have 3i times x, that's 3ix. I have 3i times 3, that's 9i. I have 3i times negative 3i, that's negative 9i squared. All right, and all of that times x times x plus 2 cubed. I don't really have a lot of room, so I'm just going to write it as x plus 2 cubed right now before expanding. And we'll be able to cancel some things over here now. So I have minus 3ix and plus 3ix. Those cancel as they should. We learned that with conjugates. I have minus 9i and plus 9i. Also cancel because we have conjugates for multiplying. And so we can, in the next step, kind of simplify. So I have x squared plus 3x is plus 6x. I have plus 9. And then minus 9i squared, so that's minus 9. Now I squared, if you remember, is negative 1. Let me write that down up here. So I squared equals negative 1. And then we have times x. And then x plus 2 cubed. I'm going to do that as x plus 2 times x plus 2 times x plus 2. I'm going to go ahead and distribute this x in here. So x times x squared, I have x cubed. X times 6x, I have 6x squared. And then I have plus 9, and then this is plus 9. That's going to give me plus 18. And then we're multiplying it by x, so x. Then I'm going to go ahead and distribute these two. So I've got x squared, okay, plus 2x gives me plus 4x. And then 2 times 2 is 4. And that's times x plus 2. So I have x cubed plus 6x squared plus 18x times I have x squared times x, that's x cubed. X squared times 2 is 2x squared. 4x times x is 4x squared. And then 4x times 2 is 8x. Then we have 4 times x And then we have 4 times 2, which is 8. So this gives me x cubed plus 6x squared plus 18x and then we have that times x cubed plus 6x squared because we have a 2x and a 4x squared. So that's 6x squared. And then we have 8x plus 4x is 12x plus 8. And that equals, now we're going to go ahead and distribute. I'm not going to write all of the distributing little arrows over because it's going to get messy, but I have x cubed times x cubed is x to the 6th plus x cubed times 6x squared is 6x to the 5th. Remember when we multiply and we have the same base here of x, we add the exponents, 3 plus 2 is 5. We have x cubed times 12x is going to be plus 12x to the 4th. We have x cubed times 8x is plus 8x cubed. Okay, we have 6x squared times x cubed is 6x to the 5th. We have 6x squared times 6x squared is 36x to the 4th. We have 6x squared times 12x is going to be 72x cubed. 6x squared times 8 is 48x squared. I'm out of room, so I'm going to have to go down here. Plus 18x times x cubed is 18x to the 4th. Plus 18x times 6x squared. Let's see, 18 times 6 is, 60 plus 48, 108. And then we have x cubed. 18 times 12x. So 18 times 12, that's going to give us 216x squared plus 18x times 8 is 144x. And then we just need to combine like terms to get our final answer. So we have x to the 6th plus, we have 6x to the 5th and 6x to the 5th, that's 12x to the 5th. Plus 12x to the 4th and 36x to the 4th is 48x to the 4th. Plus 18x to the 4th is going to be 66x to the 4th. Plus 8x cubed and 72x cubed is going to be 80x cubed plus 108x cubed is 188x cubed. Plus, and then we have 48x squared plus 216x squared. That's going to give us 264x squared. And then we have plus 144x. So this is our polynomial. Notice that it is 6th degree. We're supposed to have real coefficients. Well, we have an understood 1 here, 12, 66, 188, 264, and 144. Those are all real numbers. And we do have a leading coefficient of 1. There's an understood 1 in front of x to the 6th. If we did have a condition that we have a different leading coefficient, like 2 or 3 or something else, what I would have done is put it out in the front right here. I would not have multiplied it across until the very end, just because if I multiply it across, somewhere in one of these steps, it's going to make our numbers a lot larger. We have to deal with multiplying larger numbers. Better just to wait, go ahead and work with everything else and wait to distribute that number across your polynomial. Now, something to keep in mind is that if you do decide to try to distribute the leading coefficient in one of these first steps and not one of the final steps where the polynomial is expanded, then you need to make sure that you only distribute it to one of the factors. Because by doing that, it's going to end up being multiplied by all of the other ones anyway. Like for instance, if I put 2 here and I distribute it to this factor, this x, right, will become a 2x, which will be multiplied by each of the factors that we have in here. So we have this x cubed, it'll be multiplied by x, and x. So you'll end up with a leading term of 2x to the 6th. But if you make the mistake of putting the 2 inside each factor, right, you're going to have a 2 to the 6th, x to the 6th, because you're going to have 2 times 2 right here, times 2 right here, there's a 2, and then here this is a cubed term, so you'd actually have to expand this a little more to even put it in here, but whenever you're done expanding this part here, you will have, if you have a 2 there, it's going to be 2 cubed x cubed. So you really need to wait until one of the final steps where the polynomial is already expanded to multiply in your leading coefficient. But we were only given a leading coefficient of 1, so there's no extra number to multiply. It's just a 1 there. And then, of course, we have our zeros right here that helped us to create our polynomial. So I hope you understand a lot more how to do a problem like this when you come across it. I'll see you in the next video.